Dear students, welcome to this video number 6 on simultaneous faults. In this video, we shall deal with the interconnection of two-port networks. And this is our third learning outcome. In this interconnection of two-port network, we shall deal with series-series interconnection, then parallel-parallel interconnection, then series-parallel interconnection. This knowledge of interconnection of two-port network is required to analyze the simultaneous faults. So series interconnection, it is required to analyze said type of simultaneous fault, whereas parallel interconnection concept is required to analyze Y type of fault, and series parallel interconnection or vice versa parallel series interconnection is required for analyzing H type of simultaneous fault. So we will see if there are two-port network connected in series parallel or series parallel combination, then how to get the equivalent two-port model. So let us start with series connection. In the question paper, they ask derive the two-port equation for series interconnection of two-port networks. So now let us take two-port networks. So I will write here the way you have to write in the exam also. So let us consider two-port networks. Connected in series. So let us have here, I will show the diagram. So let us have, we have one two-port network. So let us say this is a two-port network. I will call it as 1. Then let us have another two-port network. Let us name it as 2. And we have this input port to these networks. This is the output port. This is the input port. And let us have the output port like this. Okay, now these two networks, they are connected in series. Okay, how they are connected? When we say they are connected in series, in the sense that the current is same. So what I will do, let us have this connection, and you can draw this like this. Now the current is same. As I said, I1 is flowing here. So this current comes out of this here, and same current flows here, so this is also I1. Okay, and let this be the I2 current, and the same flows through this comes over here, and this is also I2, so they are connected in series. Now let the voltage at this series connection be V1, let at this, let it be V2. Now we want a equation relating these four parameters V1, I1, V2, I2, and a similar in the fashion like uh, so. Okay, so we will derive it later. Now let the voltage at this be V1 dash. Here let it be V2 dash. Here it is V1 double dash. Here it is V2 double dash. Now here the current is I1. Here the current is I2. So now how we can define this two-port network 1? Two-port network 1. So this is the same way how we should write in the exam. Two-port network 1 can be defined as, or can be modeled as, you can write, can be defined as, can be defined as V1 dash, V2 dash. So this is our uh, equal to Z11 dash, Z12 dash, Z21 dash, Z22 dash, and let the currents be, we know that these currents are I1 and I2. Okay. Similarly, two-port network 2, two-port network 2 can be defined as, can be defined as, we can write like V1, V1 double dash, V2 double dash equal to Z11 double dash, Z12 double dash, Z21 double dash, Z22 double dash, and we will have same currents I1 and I2. So these are the two models we have for each of the two-port network. But there is a constraint equation. What is the constraint equation? But when these two networks they are connected in series, what we will have? We will have V1, it is equal to V1 dash plus V1 double dash, and V2 it is equal to V2 dash plus V2 double dash. So if you put these two in the matrix form, in matrix form, V1 V2 is equal to V1 dash V2 dash plus V V1 double dash V2 double dash. Now substituting for V1 for this vector and this vector from equation say A and B. So we can write this as equation A and B, substituting A and B, A and B, we get V1 V2 is equal to, here we'll have Z11 dash, Z12 dash, Z21 dash, Z22 dash, and you will have I1 I2 plus you will have Z11 double dash, Z12 double dash, Z21 double dash, Z2 double dash, and here we will have I1 I2. Now I1 I2 can be taken common and these two can be combined. So Z11 dash plus Z11 double dash, Z12 dash plus Z12 double dash, Z21 dash plus Z21 double dash, Z22 dash plus Z22 double dash, and we will have here I1 and I2. So this is equal to, we can write like Z11, Z12, Z22, Z21 and Z22, I1, I2. Here we will have vector V1, V2. So this is how we have obtained the complete model of two-port networks connected in series. Okay, now let us go to the next uh, parallel interconnection. So again, you can start with like, let us let us consider two two-port networks connected in parallel. Okay, now let us have two networks connected in parallel. Say we have this two-port network 1 and we have two pair of terminals, input pair and output pair. Let us have another two-port network. This is two-port network, two input pair and output pair. Okay, now let us say that they are connected in parallel. In the parallel, voltage will be same and current will be divided. So suppose this is the so what we can do, this we can connect it to over here, and this we can connect it over here. Similarly, we can connect these over here. Now these two networks, they get connected in parallel. Now say this current is I1 and this current gets divided. Say here goes I1 dash and here goes I1 double dash. Okay, say this current is I2 here and it gets divided into two currents. Say this is I2 dash and here it is I2 double dash. Let the voltage be here V1 and the voltage be V2 here. Now let us see how we can get the complete model of these two networks connected in parallel. So let us first define the two-port equation, two-port network, two-port network 1 can be defined as can be defined as so here we will have now here we will have I1 dash, okay, and you will have I2 dash equal to, now we will have a parameter say y11 dash, y12 dash, y21 dash, y22 dash, and here let the voltages be V1 and V2. Similarly, two-port two-port network 2 can be defined as we'll have the equations I1 double dash I2 double dash equal to y11 double dash y12 double dash y21 double dash y22 double dash. Here we will have V1 and V2. Okay, but what is the constraint in this connection? But the constraint equation is that I1 is equal to I1 dash plus I1 double dash. Similarly, I2 is equal to I2 dash plus I2 double dash. In matrix form, you can write in matrix form, we get it like I1 dash, this is not I1, not I1 dash, this is not I1, I2, it is equal to I1 dash, I2 dash plus I1 double dash, I2 double dash. Now substituting, let this equation be A and let this equation be B. Now substituting for this vector and this vector from equation A and B, from equation A and B, we can write this matrix as I1, I2 is equal to Y11 dash, Y12 dash, Y21 dash, Y22 dash plus Y11 double dash, Y12 double dash, Y21 double dash, Y22 double dash. This is entirely and what I have done, I have taken the common term, that is V1 and V2. V1, V2. Now if you add these two matrices, we will get this as Y11 dash plus Y11 double dash, Y12 dash plus Y12 double dash, Y21 dash plus Y21 double dash, Y22 dash plus Y22 double dash, and we will have a vector V1 and V2. So we can write this matrix as Y11, Y12, Y21, Y22. This is V1, V2, and the input current vector is I1 and I2. So this is the model, Y parameter model for the complete network where two networks they are connected in parallel. Now let us go to the last one, that is series parallel interconnection. Okay, so again we can start. Let us consider two two-port networks connected in series parallel. So the input pair is connected in series and the output pair is connected in parallel. So let us have two networks like this. So let us take this as two-port network 1 with the input pair and the output pair. Let us have another network, two-port network 2 with the input pair, output pair. Okay, now let us say that the input pair is connected in series. So we have connected in series, so current it will be same. So let us have this current as I1, which is same over here for the two networks. Let the voltage at the input pair V1 and let us this voltage be V1 dash, this is V1 double dash. Now let us say that the output pairs they are connected in parallel. So how they are connected in parallel? So say this connected here, this is connected over here, and now the input, this is the current I2, this gets divided into two currents, I2 dash and I2 double dash, and the voltage be V2. Now let us define each of the ports. Two-port network 1, two-port network 1 can be defined, it can be defined as now I will use hybrid H parameter model. So we have V1 I2 equal to, so this is V1 and this is I2 dash over here now. Okay, sorry, this is V1 dash and I2 dash equal to Y11 dash, sorry, H hybrid parameter H11 dash, H12 dash, H21 dash, H22 dash. I'm modeling, so you can write more specifically like two-port network can be defined in H parameter as. So I'm writing implicitly over here. So this okay. So here it is I1 and here it is the voltage V2. Okay. Similarly, two-port network, two-port network 2. Okay. In H parameter, in h parameter, we can write it like this is v1 double dash I2 double dash equal to h11 double dash h12 double dash h21 double dash h2 double dash, and here we will have I1 and V2. Okay, but what is the constraint equation? But the constraint equation we can write for voltage V1, which is equal to, we can see this V1 is equal to V1 dash plus V2 dash. So it is V1 dash plus V2 double dash, sorry, V1 double dash. Okay, and what is I2? So we can look at here I2, it is equal to I2 dash plus I2 dash plus I2 double dash. So you can write I2 is equal to I2 dash plus I2 double dash. In matrix form, we can write in matrix form, we get it like V1 I2 equal to V1 dash I2 dash plus V1 double dash I2 double dash. Now let this equation be A, this equation be B. Now substituting for this vector and this vector from A and B, substituting A and B, we get V1 I2, it is equal to you can have h11 dash h12 dash h21 dash h22 dash plus, here we will have h11 double dash h12 double dash h21 double dash h22 double dash, and I can take a common term over here, that is I1 and V2. So if you combine this, then we will have h11 dash plus h11 double dash h12 dash plus h12 double dash h21 dash plus h21 double dash h22 dash plus h22 double dash, and then we will have this I1 and V2. So we can write it as H11, H12, H21, H22, I1 and V2, and the input vector V1 and I2. So this is the equivalent H parameter model for the equivalent circuit for two-port networks connected in series parallel combination. Now in this video, up to this only, we will continue in the next video. Thank you very much.